This is Mr. Max with Sunco from Mathematics. So what I'm going to do today is I'm going to do a three-part series on linear programming, or also known as linear optimization. Okay, so we are going to look at things like the maximum or lowest or greatest or minimum in order for us to establish a mathematical model to some real life situations. But first, I'm going to look at just graphing the linear inequalities and starting with simple ones really. Your syllabus also has that information, and what we do here is we also shade the unwanted areas or regions. Okay, so we're going to start off by taking them um, in bits and pieces really. I'm going to start off here, and this question says you're supposed to draw on a Cartesian plane the inequality x is greater than -1. So what you want to do is you want to draw the line x is equal to -1, but you must be careful because that inequality there does not have a all equal to, which means then the -1 is not included. So the line that you're going to draw will have to be a dotted line like what I did here, okay, or a broken line. And now you're going to have to shade the unwanted region. So because it's greater than, and for greater than you should always remember, all right, for this particular case, you are looking for the wanted region is on the right side of this line. If x is 1, it is definitely fitting that inequality. If x is 2, so on the right side is the region that we want. So what you do is you shade the opposite of that particular line. Okay, so what we do is we shade the unwanted region. Let's bring in another one. This one says x is less than or equal to -3. So what you have here, you have a solid line here, and then obviously all the values of x that are less than or equal to -3 is on the left. So then you shade whatever is on the right, because on the right is the opposite of that. Y is greater than or equal to 2, so you're going to draw the line y equals to 2. It's a solid line. And what you realize, values of y that are greater than 2 is where you realize I haven't shaded. So I shade the ones that I don't want, which is under the line, below that line, y equals to 2. Okay, so we have another question here which says that y is greater than 0. So essentially you are looking for values that are above this. The wanted region is above, where y is greater than 0, like 1, 2, and so on. So then you shade the unwanted region, which is below the line that you are shading. And x is greater than 0. This is nothing but the y-axis, but you have to be careful here. We're looking for x is greater than. Now, all the values greater than 0 are to the right of the line. So then you shade the left side, which is the unwanted region. And also in both these instances, you are supposed to have a broken line here. Okay, so in this question here, we have got an inequality like this one here. So what you realize is that there is extremes here. There is a 3 here and there's a -1, which is shaded. And the way that we will do this inequality considers those extremes. So it's going to be the values of y that we are considering because of the horizontal lines of the inequality here. And this line here, this particular line on top here, all right, this line represents, if you look at here, this particular line, it represents a value of y that is less than 3, and that is why we shaded the part on top there. Okay, and this particular line here represents the value of y which is greater than or equal to -1. So when you combine these two inequalities and you have your biggest value here and your smallest value here, what you should always remember with inequalities is that these signs are always facing to the right, and we know that y is greater or equal to because it's from here. So that is how this particular inequality should be considered with your limits on both ends. All right, so I'm going to bring in another one here for you to understand. So we have got the inequality here, the diagram, so to speak, and you're supposed to write what inequality is represented by this particular diagram here. So these are lines that are cutting the x-axis, and they are both solid lines. So here, this is the line x is equal to -1, and this is the line x is equal to 2. So again, we have as an inequality here. So you realize that what is shaded is values of x that is bigger than. So this inequality represents x that is less than or equal to 2. That is what is unshaded here. And this particular part here represents values of x, all right, that are bigger than or equal to -1. So when you combine these two, all right, you should end up with the same thing. X is less than or equal to 2, and x is greater than or equal to -1. So what we're looking for is an inequality where you have the extremes listed like that. Okay, so this is another example, but here when you look at the lines or the inequalities are cutting the x-axis, and that is why I prefer we use then the x in the middle there. Okay, let's bring in another one here. So here you have got four inequalities really, but if you have to look at them individually, you probably realize, let me do the y's, for example. This two represents the y. This is a dotted line which are values of y that is less than 2. Okay, that is what this region represent. And here you have got values of y which is greater than -3. That is what this region here represent. When you combine these two, you're going to have y in the middle, and y is less than 2, for example, and also greater than -3. So what you must remember is your small number is always on the left, and your big number is always on the right. So that is what that particular one represents. Now you then do the same for the ones of x. When you realize here, this is the one x is less than 4. Okay, it is also a dotted line, and this one here is represented by x is bigger than -3. So once you combine these two and you put your x in the middle, you put your big value to the right, your small value to the right, inequality signs, they face in that direction. So when you compare them, and to compare to what I have done here and here, you realize that it's exactly the same thing. X is less than 4, okay, and also x is greater than -3. So these two will be our solutions for this particular question. All right, so there's going to have some y range as well as the x range, and then you write them down and you have your solutions like what I have done here for x, and then also the same for y. Okay, let's bring in another one that is similar. So we have got, again, something that is similar, and I will pause the video and see if you can figure it out. Okay, I hope you have managed, and I hope you have realized that x is less than 1. Okay, because it cuts the y-axis here, the x-axis at 1. So all of this unshaded part represents less than 1. And then from the -2 perspective, you have got x is greater than -2 or equal to, because the line is solid. And when you do the y, it has to be from 0 to 4 with the line y greater than 0 is solid, so therefore it's included, but less than 4. So that is the two possible answers. Okay, so we're going to look at when we graph inequalities that involve two variables, x and y. So um, once you do, you get an inequality, you replace that inequality sign, whether it's a less than, a greater than, or less than equal to, or greater than equal to, with an equal to, because it's easy for you to graph the line. Okay, so when the line has got or equal to, it's a solid line. When it has no or equal to in the inequality, it's a broken line or a dotted line. Now, when you shade the unwanted region, you will see it is obviously sometimes better if you make the equation y the subsequent formula. But when you get inequalities like greater than, say y is greater than something, then or greater than or equal to, the wanted region is above the line, and then you shade what is under, and less than or less than equal to the wanted region is below the line, and you shade the opposite side. But you're going to see once we do some questions. So we have got a question here that says shade the unwanted region for the following inequalities. All right, so this is a less than, and less than inequalities. We are going to shade what is below the line. All right, but first of all, let us write it as an equation. Once you write it as an equation, you realize it's going to be a dotted line because that or equal, that less than says there's no or equal to, so it's going to be a dotted line that you're going to draw. Now I'm using the dual intercept method where you make x 0 and y 0. So for example, in this equation, when uh, where the line cuts the x, okay, it's going to be at the point where y is 0. So when I make y 0, I solve, I get x to be 5. So essentially, I have then a point, for example, x is going to be 5, okay, and my y is going to be 0. So I can plot that particular point, okay? And the other one that I'm going to find is when y, when x is 0, so that's 0 here, and I get y to be 5. In fact, these ones are supposed to be very easy for you to graph because you have got that x plus 5, negative x plus 5, you should be able to find it very easily. Okay, so the solutions, therefore, we know now how to draw our line. Our line is going to cut the x-axis. So suppose this is the equation, or this is the Cartesian coordinate system. When x is 5, 0, 5, 0 is a point here, and y is the point 0, 5. So 0, 5 is the point here. So what you expect then is to draw a straight line, and that straight line passes right through those 2 points, okay? Passes through those 2 points. All right, and what we are saying here, the inequality is less than, and because the inequality is less than, okay, because the inequality is less than, remember what we said about less than inequality, we are going to shade whatever is, the wanted region is below the line, so we're going to shade on the opposite direction. We're going to shade what stuff that is above there, okay, and that is what you're going to realize what we're going to get, okay. So let's have a look at that inequality, and you can see I have done it here, and I have done the shading, and the inequality passes, or the line passes at x, where x is 5, 0 and y 0, 5, and again because of that less than, it is supposed to be a dotted line. All right, so once you want also to determine whether you have done your shading correctly, you can choose a point like the origin here, 0, 0. And once you substitute that 0, 0 into the inequality, you realize that yes, 0 is less than 5, which is true. So this is the wanted region, and therefore you shade up what is above the line, because what is below the line, when it's less than or less than or equal to, is what is the truth. So the unwanted region is above, and that is the region we shade. You could also choose any other point here, 1, 2, and so on, because you cannot always use the point 0, 0, because some lines, they pass through that point, and then it would be very difficult for you to determine. Okay, so here I've got 3x plus y is greater than or equal to 9. Now greater means you're supposed to shade whatever is below that line. Okay, so we're going to have a look at this particular question. So first we're going to draw the line y equals to negative 3x plus 9, or you can even leave it as 3x plus y equals to 9. And then you make x 0, find what is y, and y 0, find what is x. So when I make y 0, x is equal to 3, which means this is a point that can be plotted when y is 0, x is 3. So this will be the point 3, 0, Okay, and the other one, when x is 0, y is 9, so that is the point 0, comma 9. So these points can therefore be plotted. So as you can see, I will indicate the point 0, comma 9 here, and the one down there is 3, comma 0. Okay, so also because we said this line, if you pick a point, any random point, you will realize here you obviously can't now use the origin. But suppose I take the inequality and I will write it down here for you to see what I mean by shading what is below the line, because it's a greater than. All right, if you take the inequality, which was 3x plus y is greater than or equal to 9, and for some reason, if I choose the point, and I'm just taking a random point here, this is the point 3, comma 5. I hope you can see that. All right, so that's the point 3, comma 5, and you must make sure that you don't get confused. This is x here, and that is y. So if I substitute 3, and then I substitute the x value that I'm going to get and the y value that I'm going to get. Remember, if it's true, then it means we shade the opposite, as you can see in my diagram. So if I input the value of x, x is 3 and y was 5. So when you do this, this is 9, and 9 plus 5 obviously is going to be greater than 9, okay? Because 9 plus 5 is nothing but 14, and 14 is greater than or equal to 9. So this region here is true, and because it's true, you shade on the opposite side. That is why we did the shading here. So I'll emphasize again, as you look through this question, whenever you are dealing with a greater than, we shade what is above the line is the wanted region, and above the line is this region here that is not shaded. So when you shade what is below the line. But I will also say, just try to pick a point, whether it's in the shaded part or the unshaded part, before you start shading, and see if it makes your inequality true, and then you will know if it's not true, then you shade in the opposite direction. Okay, so question 4 is a very similar question. Now, what you have here is you are given three inequalities. Now, the inequality is x is greater than negative 1, y is greater or equal to 2, and x plus y is less than or equal to 5. So you are supposed to graph all three of them, and then the unwanted region, you're going to have to write that letter R there. Okay, so now I'm bringing in my Cartesian plane. So I'm going to take the first one here. The first one, I'm going to draw the line x is equal to negative 1. But it's going to be a dotted line like that. So values of x that are greater than negative 1 are on the left side of the line. So we're going to shade whatever is on the right side is the truth. So we're going to shade whatever is on the left side, like what I've done here. Then y equals to 2 is going to be a horizontal line and a solid line for that matter. And it's greater than. So we're going to shade everything that is below that line, because everything below that line is not greater than 2. All right. So the truth, or the part that we want, is above this. And now we're going to draw the line x plus y is less than 5. Now this particular one, x is less than or equal to 5, is very easy for you to do. If x is 0, y is 5. If y is 0, x is 5. So the point is going to cut at 5, at the y-axis at the point 0, 5, and also at the point 5, 0. So when you draw this line, it should be very straightforward. So I repeat, you use quickly, when x is 0, what is y? All right, 0 plus y will give you 5. And again, when y is 0, you will see that x is 5. Okay, so these are going to be the 2 points. So what we are considering now here, remember, we are dealing with a less than. So anything below the line is true. So we're then shading what is above that line. So our required region is that particular part that is not shaded. So be very careful that you pick the right stuff. Now, something else that you can do whenever you get to this particular point is you can choose a point here inside the region, and you see whether this particular point, the point 1 comma 3 for example, if you check it out on all three of the inequalities, whether it's going to work. Okay, so I'm going to quickly do that so that you can see. So I'm going to pick the point here 1 comma 3. So when you pick the point 1 comma 3, all right, just to make sure that if we check it on all three inequalities, is it going to work out? So that's the x value, that's the y value. So when we take the first one, if x is 1, yes, 1 is definitely greater than -1. If we take the second one, where you have y is greater than -2, so 3 is greater than or equal to 2, so that works out. So when we add them, okay, when we add them, so 1 plus 3, we are going to get 4, which is definitely less than 5. So it works then for all three. And this here is then the required region that we are looking for. Okay. So I also encourage you to do the same. You just pick a point and then you see if it works for all three, or however much inequalities you are given, in order for you to know whether you have picked the correct region. All right, so we have got another one here, and I'm going to pause and I'm going to allow you to attempt to do this one here. So remember, when you are getting to 5x plus 3y is less than 15, you have to draw the line. 5x plus 3y is 15. You can use that, make x to be 0 and y to be 0, or you can make y the subject of the formula in order for you to write the line in gradient intercept form, and it's also going to be dotted line. So in fact, all three of them will be dotted line. And here, this one here is nothing but going to be x is equal to 2x is equal to 3, and then x is equal to 3 divided by 2, okay, which is basically x is equal to 1.5. So this line here, if you have your Cartesian coordinate system, is going to be the line 1.5. All right, that's a rough drawing. I was trying to give you an idea what you need to do. And the first one that you have on top there, y is greater than 0, okay, so that is going to be nothing but the x-axis, okay. Okay, so where you look at where the line cuts, so I've been using the last one to explain here. If I make y 0, x is going to be 3. If I make x 0, y is going to be 5. And if you take the first one that I said, you get to 1.5. And the other one is nothing but the x-axis. I hope that your diagram looks something like this and your r is in that region. So all of these three lines are broken lines. Okay, so we have question 5 here. So this particular question give us the graph has already been drawn for us. So we need to come up with the inequality. So the first part, so that is line 1 here, that horizontal line that you see that passes at 8. This is line 2 here, and this line 3 here, the pink one, so to speak. So you must find the equations of all of these lines, line 1, line 2, and line 3. Well, when you look at line 1, you can see it's a horizontal line, and horizontal lines they start with y equals to some number. All right, so it cuts the y-axis at 8. It's nothing but y equals to 8. Remember, here you were looking for the equations, not the inequality. Now, when you do line 2, so I picked 2 points. I picked the point 0, 6, and I also picked the point 6, 0. You can pick any points on this line. The reason why I did that, I want to calculate the gradient. So when I calculate the gradient, remember delta y over delta x, I get that the gradient is -1, and surely the line is sloping in that direction, like a downhill direction, so the gradient should be negative. Now that I know what the gradient is, okay, I just can see from the line, where does the line cut the y-axis? It cuts it at 6, so the equation then is nothing going to be y equals to -1x plus 6, and that's the equation of that line there. So I'm going to do the same for line 3. So if I bring line 3 back here, so what I did is line 3, I picked 2 points. I pick a point randomly on the line. I picked the point 3, 5. and I pick another point, um, 0,2. All right. So the reason why I want to do that is I want to find the gradient like I did the previous one. And to find the gradient here, you realize the gradient is equal to 1. Okay. One up, one across, one up, one across. So the gradient is 1. And now I can also see from this that the line cuts the y-axis at 2. So the y-intercept is 2. So I can complete my line as y equals to x plus 2. Right, so the B part says the unshaded region, which is here labeled by the R, is now defined by three inequalities. You need to write down the three inequalities. So the very first one, you look at the wanted region and then the inequality. So if I look at this horizontal line, line 1, the wanted region is below, and because it's below the dotted line, then that's the less than, okay? Because we shaded what was above that. Then line 2, the wanted region, if you look at that, the wanted region is above this line. So when it's above the line, it's greater than or equal to because it's solid. Now line 3 also is above. The wanted region is above the line. So we're also going to shade greater, or we're also going to have greater than or equal to. And then the x plus 2 and minus x plus 6 is coming from your equations. Right, so I hope that you have picked up on a few things here. Pause the video, rewind, and check again. So I'm going to do the second part, which is going to deal with finding the maximum and the minimum. And then I'm going to look at some values or some real life situations where we apply the principles of linear programming, like word problems. So I'm going to do 2 more videos on the topic, and it should cover whatever your syllabus is requiring.